Good afternoon, students. Welcome back once again to the mathematics class. In the last class, we have seen and discussed exercise 8.1, that is application of integrals. So now we are moving to our next concept, that is area between two curves. The last class we have discussed area under the curve. Now area between two curves. It is area between two curves. Let's see. First, let us consider a graph for this. This y-axis is x-axis, right? X-axis, y-axis, and it is origin, right? So let's see. We have two curves here. See, it is one type of curve, right? So and we have one more type of a curve, right? Two curves we have. This curve is what? Upper curve is it is y equals to f of x, and this lower curve is y equals to what? G of x. These two curves we have. So now here, and they are bounded, or we can say both the curves are intersect at the point. Let us take it as intersection point. It is point x equals to a, and it is x equals to b, right? So we are considering the strip here like this vertical strip. So it's a vertical strip with this dx, and this term what we can say, it is nothing but this whole area. The shaded region what we are taking this whole area is nothing but our bounded region, right? This whole region is what it is. It is our bounded region, that is nothing but y equals to f of x minus of g of x. Y equals to f of x means this area, this much area. Y equals to f of x means the area between the curves we are taking. First, y equals to f of x, simply y equals to f of x means this much area. This much area. Y equals to it is f of x, right? The area below the curve, it is y equals to f of x minus of g of x means this curve. This area is nothing but this much. So we are subtracting whole area, this area, that is we can take it here, take it as L, M, N, L, M, N, O, and this it is as P somewhere, P, and this as Q you can take. So the area what we are taking here, area L, M, Q, N, O minus of area L, M, P, N, O. L, M, P, N, O, it is minus. This whole term, the whole area is dividing, subtracting by this much area. So we are removing, subtracting this much here, then what we are get here? We get the bounded region. This is the shaded region what we have. We get this region, right? So let's see the given curves. To find, it's in general, to find area enclosed by the curves. It is y equals to f of x, it is a type of a curve, and y equals to g of x is another curve where f of x is greater than or equals to g of x in closed interval a comma b, right? So let's see, the given curves are y equals to f of x, take it as equation 1, and y equals to g of x, take it as equation 2, where f of x is greater than or equals to g of x, right? So equation 1 and 2 intersect at equation 1 and 2 intersect at point x equals to a and x equals to b. Very simple. So first this much area we can find, in that we can reduce this area, right? So finally we get the bounded region, that is y equals to f of x minus g of x. So let's see here, intersect point at x equals to a and x equals to b, taking vertical strip here, taking vertical strip, already we have taken vertical strip as height, elementary strip as height, f of x minus g of x, that is y equals to what? F of x minus g of x, and width dx. So the area dA, which is equals to f of x minus of g of x into dx. So the total area we can write it as total area A, which is equals to integration limit function a to b f of x minus of g of x into dx. Got it? Alternatively, one more type, we can say this. So it is one type, it is standard form, that is integration a to b f of x minus g of x dx. So one more time, alternatively we can write it as also alternatively a equals to area bounded by y equals to f of x between s x equals to a and x equals to b minus area bounded by y equals to g of x between x equals to a and x equals to b. So which can be written as integration a to b limit integration a to b f of x dx minus integration a to b g of x dx, right? So we can write it as integration a to b f of x minus of g of x into dx, where f of x must be greater than g of x in closed interval a comma b. Got it? So when there are two types of curves, so let's see one more type. Remark, when f of x is greater than or equals to g of x in a to c, and f of x is less than or equals to g of x in c to b, where c is lies between a and b. So in this case, how the area should be, the formula for to find the total area, let's see. For that we have a is y axis So it's x-axis, it's center point to origin. So we have the curve like this. We have the curve like this. It's the one type of a curve. So one more type of a curve we have like this. For now, it is nothing but what? It is y equals to f of x, and this is y equals to g of x, and this is y equals to f of x, right? Same curve. So it is y equals to g of x. So we are taking here vertical line perpendicular to x-axis. This one, this point of intersections, 3 point of intersection we got here. So let's see, it is x equals to a, it is x equals to c, actually it is c, it is x equals to b. Got it? So let us consider the points here. It is a, it is c, so it is p, it is b, it is q, and this one is as m, right? So this is nothing but our shaded region, is nothing but bounded region. What we have the shaded region here, it's a bounded region, right? So let's see. Here area of a region bounded by the curve. Here area of a region bounded by curve can be written as, it is total area, which is equals to area of region ALBMA, AL, actually it is L, ALBMA ALBMA, it's this reason, ALBMA plus area of region BQCPB, BQCPB, right? So second reason, this reason we are saying this one, it is first plus second one, right? So which can be written as, which is equals to integration a to c, right? So here is a to c f of x minus of g of x dx. Here f of x means this much area we are considering here, this much area minus this area, right? So f of x minus g of this term is g of x means this area, whole area, where f of x is means this my total area we get here, right? Up to from this to this area we get f of x, for f of x. Only for g of x means we get this much below area, right? This area only we get, plus integration c to be again g of x minus f of x dx. So here this term is what, this area is what, total area is g of x minus of this area, right? So it is nothing but integration c to be g of x minus f of x dx. So the area is bounded between the curve y f of x and g of x. So let's see one or two examples based on this. First example, after solving one or two example, we will go for exercise 8.2. first example, so let's see first example. First example, example number 1. Using integration, using integration using integration, find the area of a region. Find the area of a region bounded by the parabola y square equals to 4x and the circle 4x square plus 4y square, which is equals to 9. It is asked in CBSE 2008, right? So let's see solution for this one. So we have y square equals to 4x. Take it as equation 1, which is right-handed parabola, right? Which is right-handed parabola. So let's withdraw the figure here by using parabola and 4x square plus 4y square equals to 9. It is a circle, right? So let's withdraw so which is nothing but x-axis, it's a y-axis, it's a y dash, it's x dash, right? So we have a circle with the center 0, 0 and radius is what? The radius is what here? Radius is 3 by 2. Let's see what it implies. 4x square plus 4y square equals to 9 means by taking 4 common here, what we get? X square plus y square equals to 9. So x square plus y square, which is equals to 9 by 4, which can be written as x square plus y square, it is 3 by 2 whole square, right? 3 by 2, where origin, it is x comma y is 0, 0 and r value is what? 3 by 2. x minus h, that is y minus k. H comma k is 0 comma 0 here, and r value is 3 by 2. So by 3 by 2 we drawn the figure here. 3 by 2 in this one the sense 1.5, right? So here it is 1, it is 1.5, means here it is 2, in between it is exactly right. So somewhere it is 1, so it is 2, right? It's 1.5 means in between 3 by 2 r value radius. So now we have a parabola also, right-handed parabola, so which is like this. So here we have to find the region, bounded region means this whole region we have to bounded region here. We have to find here this bounded region, right? The shaded region what we have is nothing but it is a bounded region. So for that we have to take a strip here, vertical strip we are taking here, right? So point of intersections can be found by simplifying parabola and circle equation. We get point of intersection, that is nothing but point P, it is origin O, it is point P. What we get the points 1 by 2 comma root 2. Here it is point A, 3 by 2 comma 0. So it is point Q. We get 1 by 2 minus root 2. So after simplifying we get the values. So let's see which is a circle, which is a circle with center 0 comma 0 and radius is 3 by 2, right? So now what we have, x square plus 4x, which is equals to 9 by 4. So which implies 4x square plus 16x minus 9 equals to 0. So now it is in the standard form. So finally what we get, x equals to minus 16 plus or minus under root of 256 plus 144 upon 8. So minus 16 plus or minus 20 by 8 it is. So finally simplifying what we get here the values, minus 36 by 8 comma 4 comma 8, which is equals to minus 9 by 2 1 by 2, right? So negative value we neglected, only positive value we have considered here 1 by 2. So negative value is neglected here. So x equals to 1 by 2 because x equals to minus 9 by 2 is not possible. But it is not possible. So putting in 1, y square equals to 4 times of 1 by 2, which is equals to 2. So what it implies, y equals to plus or minus root 2 it is. So thus 1 and 2 intersect at P. So thus 1 and 2 intersect at P, 1 by 2 root 2 and Q is 1 by 2 minus, already we have mentioned in the figure. So the required area is, 2 times of shaded area. 2 times of a shaded area. For that reason what we can take here, which is equals to 2 times of integration 0 to 1 by 2. First limit we are taking, that is 2 root x into dx. Again integration 1 by 2 to 3 by 2, that is 9 minus 4 x square by 2 into dx, right? So by taking y value we are substituting here y dx. So 2 outside as it is. Again 2 also kept outside. Integration root x integration is x to the power of 3 by 2 by 3 by 2, that is 0 to 1 by 2, plus already 2 take outside. So here what we get, 2 by 2 integration 1 by 2 to 3 by 2 is there. So just we are taking 2 by 2 here. 2 by 2 outside, integration 1 by 2 to 3 by 2. We can write 3 by 2 whole square minus x square dx. So here which can be converted now to as it is. It is 4 by 3, when denominator goes numerator it becomes 4 by 3. It is 1 by 2 to the power 3 by 2 by substituting limit upper limit minus lower limit is 0, plus of x under root of 9 by 4 minus of x square by 2 plus 9 by 4 by 2 sin inverse x upon 3 by 2, limit 1 by 2 to 3 by 2. So which is equals to 2 into 4 by 3 as it is, 1 upon 2 root 2 it is, which can be written as 1 upon 2 root 2, plus this term becomes 0, 3 by 2, 9 by 4, 9 by 4 it is get cancelled, 0, this term 0 plus 9 by 8 sin inverse of 1 minus 1 by 2 by 2 under root of 9 by 4 minus 1 by 2 plus of 9 by 8 sin inverse 1 by 3, right? So which is equals to 2 as it is, 2 ones are 2, that is root 2 by 3 plus 9 by 8 sin inverse 1 is 5 by 2 minus of 1 by 4 root 2 minus 9 by 8 sin inverse 1 by 3 it is, right? So again which is equals to, we can write, just multiply 2 inside, 2 root 2 by 3 plus 9 by 8 by minus 1 by 2 root 2 minus 9 by 4 sin inverse 1 by 3. So the final value which is equals to 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 plus root 2 by 6 square units is the required answer, right? So it is the required area. Required area is 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 plus root 2 by 6 is the required area of the given circle and parabola. It is y square equals to 4x side, 4x square plus 4y square equals to 9. So the area is 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 plus root 2 by 6. So next, one more problem we will see. Example number 2. Find the area of the region included between first one is the parabola y equals to 3 by 4 x square and the line 3x minus 2y plus 12 equals to 0. So which is asked in NCERT Punjab Board 2009 and in CBSE 2008 also, right? And one more second one, similar type. The parabola the parabola 4y is equals to 3x square and the line 3x minus 2y plus 12 equals to 0. So it is asked in Jammu Kashmir Board in 2012 and AICBSE 2009. Right? So let's see solution for this one. Both questions are same here, just they have cross multiplied here. Y equals to 3 by 4 x square, here 4y equals to 3x square. So 192 by considering 192, the given parabola is 4y equals to 3x square, that is nothing but y equals to 3 by 4 x square. Take it as equation 1 and the given line is 3x minus 2y plus 12 equals to 0. This is equation 1, that is equation 2. Putting the value of y from 1 in 2, we get, just substitute the y value of equation 1 in equation 2, we get, that is 3x minus 2, 3 by 4 x square plus of 12 equals to 0, which implies 3x minus 3 by 2 x square plus 12 equals to 0, which implies 6x minus 3x square plus 24 equals to 0 again, which implies x square minus 2x minus 8 equals to 0. So on simplifying, what we get, x minus 4, x plus 2 equals to 0 finally, which implies x equals to 4 comma minus 2. Just we have solved the quadratic equation here. So putting in 1 y equals to 3 by 4 square, which is equals to what? 12, and y equals to 3 by 4 minus 2 whole square, which is nothing but plus 3. So we can draw the graph now by the points. So let's see. This y-axis, this x-axis. So it is nothing but our parabola, right? So now considering this point here, so it is minus 2 comma 3 a, it is L, it is point B 4 comma 12, this one is M, and it is origin 0 comma 0, and the line which moving from this to there. See, this is nothing but our point of intersection. This is the bounded region. What we are going to find here. So let's see. Hence, we have line to intersect the parabola. Hence, line to intersect parabola 1, the point A minus 2 comma 3 and B 4 comma 12, right? So the required area, we have the formula. Required area AL MB minus area ALO plus area O, right? So let's see. Integration minus 2 to 4 it is. Minus 2 to 4, 3x plus 12, that is y value, y dx minus of integration minus 2 to 0, 3 by 4 x square dx plus 0 to 4, 3 by 4 x square dx. From equation 2 we have, from 2 equals to 3x plus 12 by, so now 1 by 2 outside, integration of 3x plus 12 is, that is 3 x square by 2 plus 12x, it is minus 2 to 4 minus of 3 by 4 x cube by 3 minus 2 to 0 plus 3 by 4 x cube by 3 plus 0 to 4, right? So now 1 by 2, 24 plus of 48 upper limit minus 6 minus 24 lower limit minus 3 by 4 0 plus of 8 by 3 plus 3 by 4 64 by 3 0. So simplifying this, what we get here, 72 plus 18 minus 2 plus 16, which is equals to 45 minus 18, finally we get 27 square units is the required bounded area, right? So with this, we'll conclude our today's lecture. In the next lecture, we'll see exercise 8.2. So till then, take care, stay at home, stay safe. Thank you.